Next presenter is Semih.
Hi, I'm Semih from Hacettepe University. Today I'm going to talk about our recent effort on multimodal machine comprehension. I'll be introducing RecipeQA, which is a multimodal machine comprehension dataset constructed from cooking recipes. To give you background, in reading comprehension task, the goal is to find an answer cast against a context, cast against a piece of text. So in recent years, there have been a surge in the number of question-answering datasets, which have each of these datasets have different strengths and weaknesses as well. SQuAD is one of these benchmark datasets in reading comprehension domain. We've observed a rapid progress on SQuAD, and much recently, a few models could outperform humans. So the question is, did we really solve the question answering task? We don't think so. So we now know that even making small changes in the context can lead to huge degradation in model performances, and simple pattern matching methods and saliency-based methods could really do quite well in various question answering datasets. One line of the, when we look at the recent development in question answering domain, we see that there is a line of work that investigates the weaknesses of neural models by introducing adversarial examples, as well as several researchers are trying to introduce much harder data sets and much harder benchmarks. So we believe today I'm going to talk about our lab's view in that direction. We believe multimodality can help us construct much harder benchmarks. So before I talk about multimodal machine comprehension, I would like to first mention the formulation of reading comprehension task. So we have a context, question, and answer triplets, as we can see here. The context, question, and answers are all in textual modality. When we look at the question answering task, which we can see as a visual counterpart in computer vision domain, we also have context, question, and answer triplets, but this time the context consists of an image, and the question and answers are in textual modality. When we look at the multimodal machine comprehension problem, we see that in generally the context might consist of both text as well as image. And often we see that question and answers are in textual modality. So today we are introducing RecipeQA, which is a multimodal machine comprehension dataset of cooking recipes. But before delving into more detail, I would like to talk about why cooking recipes are interesting at first. So there are a number of reasons why recipes are interesting for a question in a question answering setting. First of all, recipes have been with us for thousands of years, and understanding recipes is a real-world problem with several practical applications. Recipes contain procedural knowledge, and they're basically available on the web in many different formats, and often contain multimodal data with aligned images, text, as well as videos. Recipes are written by humans in unconstrained environments, and in that regard might be considered noisy. Answering questions about recipes often require common sense knowledge, and there is high divergence across authors in writing and style as well. One particular thing about recipes, they can capture cultural information as well. So now that we've talked about why recipes are interesting in a question answering setting, I would like to describe our data collection scheme. So we started collecting recipes from the food category of Instructables.com, which is a how-to website, and filtered out non-English recipes and eliminated unreadable contents, then selected recipes with more than 2 steps. In total, we ended up around 20,000 unique recipes, and we made sure that each recipe is copyright-free. So let's examine the anatomy of a recipe in RecipeQA. So we have an arbitrary number of steps in a recipe, and in each step we have step titles, arbitrary number of images, as well as step descriptions. So when we think about a recipe, often recipes start with the ingredients, and here we observe that the ingredients are listed in textual modality, and there is a visual information that displays the ingredients as image. And the step titles basically summarize the whole step. Recipes, steps in recipes also convey information about the processes, state changes, and actions through different modalities. There might be 0 to arbitrary number of images in each step. We see that there is a natural temporal flow of events. And finally, in the end, we start with some ingredients and end up with a product. So we reached our goal. So when we look at the characteristics of a recipe in RecipeQA, we have step-by-step instructions, temporal flow of events, state and attribute changes, multiple entities and objects, aligned multimodal data. We have our images are natural, and we have and the text we have is noisy, short as in step titles, long as in step descriptions. The data we have is quite structured because we have segmented steps for each recipe, but can be wild in a more granular level because authors can write whatever they want or include whatever they want. Now that we talked, we looked into details about the format of a recipe. We would like to make an emphasis on how hard is it to understand a recipe. So let's try to make a Mexican lasagna or learn how to make one. Before doing that, I'd like to show you a picture. First, when we search a Mexican lasagna on Google Images, we see that there is a very there's a high diversity in the byproducts. So the idea of Mexican lasagna might be similar, but each recipe is unique on its own. So in order to understand recipes, when we look at the data, we see that it might be quite noisy and unstructured, and the authors can include anything they seem related. In order to understand recipes, we both need visual grounding as well as language grounding, as we can see here. We also need to keep track of entities and their state changes as well as their interactions between them. Sometimes one might need to fill the semantic gap by relying on the different modality. For instance, you might not come up with the answer by just looking at the visual data or textual data. You might want to rely on you might have to rely on the accompanying modality. So we have quite aligned data For instance, we have multiple number of steps for each recipe, and in each segment of step, we have step descriptions and a number of images, often a number of images as well as descriptions, so they come quite aligned in that regard. So when we, to sum up from the beginning to the end, when we follow the instructions step by step, we end up with a food and finally reach our goal. So when we look at the RecipeQA in a statistical manner, we have around 20,000 unique recipes coming from 22 different food categories. And the splits are non-overlapping, so that none of the recipes are can be seen in another another split, and none of the question generated from that split can be seen as well. So we made sure that splits have slightly different distributions in terms of food categories. We automatically generated around over 30K question-answer pairs along with the contexts. We introduced four major question types, which corresponds to the different types of tasks, in particular textual clause, visual coherence, and visual ordering, which I will be describing in detail very soon. In textual clause task, is actually quite common in reading comprehension data sets. So reading comprehension data sets with two main differences. In the first, we have arbitrary number of steps, and in the context, we have images as well. So the goal of this task is to find the missing textual element in the question. While generating questions, we use step titles and drop one randomly. While selecting distractors, when we look at the distractors, they are close but not too close. We accomplish this by choosing adversarials from distant neighbors. The visual clause task is quite similar to its textual counterpart. The context here consists of the step titles as well as step descriptions. The goal is to find the missing visual element in the question. So in visual coherence task, the idea is to find the incoherent image in the provided candidates. And for the visual ordering task, the goal is to sort find the correct order of the images in the provided question, which would make a coherent story. So we've developed simple and neural baselines, and in simple baselines, the reader tries to answer questions without looking at the context. We adapted Hacettepe baseline for this simple baseline models. For the neural baseline models, we adapted impatient reader and used ranking loss for multiple choice selections. We used ResNet 50 to represent images and trained a distributed model to represent words and sentences and paragraphs. Here are our results. For the there are very interesting multimodal machine comprehension data sets such as MovieQA, Comics, and TQA. I would like to okay. I think I'm out of time. So RecipeQA is an interesting multimodal machine comprehension data set, the first procedural question answering data set in multimodal domain. So in summary, we have a challenge website. You can download the recipes and questions accompanying data and start developing your own models, submit your results through Codalab. We also encourage research in other directions. If you're interested, we can share the recipes with you. Thank you.
Unfortunately, there is no time for questions, so I